All right, let's go ahead and start off here on number 1 and 2. So for these ones, we're doing our inverse trig functions. And what we're going to be doing is looking in, and for the rules for sine and tan are that whenever we're doing these, we're always looking for the positive values in quadrant 1 and the negatives in quadrant 4. However, when we're doing these for cosines, we're going to be looking for the positive ones in quadrant 1 and the negative ones in quadrant 2. I'll just go ahead and run through some of these. So for sine inverse of 1, I see that sine value is up here. And so our answer is going to be the angle right there, which is going to be pi over 2. So we're looking for the sine value on the outside, and the answer is kind of on the inside. So then for the next one, rad 3 over 2, the sine value is right there, and so my answer would be pi over 3. Now for the last one there, you can see that 5 is nowhere to be found. It's actually kind of, if you think about it, it would be like way up here. So that one is too big to be on the unit circle, and so that one is going to be undefined. Anytime a sine inverse or a cosine inverse has a number that's not in between -1 and 1, that's really always going to be an undefined there. All right, next up here, I'll do my cosine inverses. So for cosine inverse of -1, I see that over here at the radian value of pi. And then for cosine inverse of 1/2, I see that right here. And so that'll be pi over 3. And then for negative rad 3 over 2, I'm seeing that over here for our cosine value. I'm looking at the x values now, and so that's going to be 5 pi over 6. All right, next up here, I'm going to find the exact values. So there's some more inverse here. So arc. So remember for, once again, for sine and for tan, we're going to be looking in quadrants 1 and 4 only. And then for cosine, we're going to be looking in quadrants 1 and 2. So for arc sine of 0, I see that is right here, and so our answer is going to be that angle 0. Arc cosine of -1, we actually kind of did that on the last page, but that's going to be over there as pi. For arc tan of 0, that is also going to be 0, because you can see at this spot of 0, the y over x would be 0 over 1, and so that's going to give me a tangent of 0. All right, next up here, tan inverse of -1. Now for tan, we'll be looking down in this fourth quadrant here for negatives, and I see that this is the spot we're looking for, because if you divide that, the y over x will come out to -1. And then this is our angle we're looking at, but on these fourth quadrant angles, we always call it the negative version of the angle right above it. So this will actually be written as negative pi over 4. If you write 7 pi over 4, you're looking at the right spot, but you do need to list that then as the negative coterminal angle. All right, next up we'll do tangent inverse of rad 3. So this is a positive tan value, so I'm thinking that that's going to be up here in the first quadrant. I think it's this spot right here, because you can see if you do the y over x, the rad 3 over 2 will be on top, and then the 1/2 will be on bottom, so that comes out to just a rad 3. So this is pi over 3. And I'll let you guys try part C. All right, I'm going to jump down here to number 7, and then the previous two are kind of similar. And so on this one, the first thing I kind of notice here is that I have a sine with a sine inverse, and whenever we have the regular sign on the outside, these can actually just cancel out, and we're going to be left with 1/6. I kind of just think of that as like a square root and a squared undoing each other. All right, next up here we'll do number 10. So for this one, whenever the inverse is on the outside, you really just need to make sure that it follows kind of our rules here for sine and tan inverse, which are the quadrant 1 and 4. And then for cosine, it would have to be either quadrants 1 or 2. So for this one here, I see that 3 pi over 4 is in quadrant 2, and so that does not work for sine. And so I need to kind of do this one piece by piece. So what I would do then is do the inside first, and so I'm going to do sine inverse of, and then the sine of 3 pi over 4 is rad 2 over 2. And so then the sine inverse of rad 2 over 2, I would look over here in the first quadrant and get that at pi over 4. So it's kind of the same sine value, but in the appropriate quadrant for sine or tan. Now for cosine, remember this is in the third quadrant as well, 3 pi over 4, but for cosine, that third quadrant is appropriate. And so I am actually just going to keep that at 3 pi over 4. All right, next up here we have like a sine with a tan, or these kind of don't match here with the inverse and the regular, and so those will never just cancel out. And so what we're going to want to do on those ones is just do it piece by piece. And so I'm going to do it first, the sine inverse of rad 3 over 2. So it's obviously looking right there. And so I'm going to say it's the tan of pi over 3. So I just did kind of the inside first. And now I'm just going to take the tangent of that same spot. So it is rad 3 over 2 over 1/2. So we multiply by the reciprocal there. And that'll just give you radical 3. All right, next up here, cosine of sine inverse of 0. So same idea, actually, I'll let you guys do these next two. So you're just going to do the inside first and then do the outside. All right, next up here, we have like a sine and a tan together. Now, what we're going to want to do on this one is actually draw a triangle. And so I'm going to draw a triangle here. I'm going to put it in the first quadrant since they say it's positive. And they're telling me that the tan is equal to x over 1. So I'm going to do the opposite side as x and the adjacent side as 1. And so now it's asking me to find the sine of the triangle I just drew. So I'm going to use Pythagorean theorem. I'm going to call this c squared equals 1 squared plus x squared. So c squared equals 1 plus x squared. And then c equals the square root of 1 plus x squared. So I'm going to put that right there. I cannot turn that into just 1 plus x. That simplification does not work if we have that addition in there. And so what I'm going to say then is that since this next piece is saying do the sine, I'm going to figure out what's the sine of the triangle I just drew. And you can see that that's going to be x over the square root of 1 plus x squared. So that's kind of everything in there I've taken care of so far. And all they're saying next is just multiply that by 4. So what I'm going to do is it's going to be 4 over 1 times whatever I got for that last answer. And so I would just write my answer as 4x over the square root of 1 plus x squared. All right, 19 is very similar to 18, so I'll let you compare that one. All right, next couple here, we're going to do the angle addition formula. So I'll go ahead and do this one, tan 195. So for this one, what I'm going to do is I'm going to break that up into two angles that I already know. So I'm going to do this as tangent of, I would say we could do, let's see, could do 135 plus 60. And so that's going to turn it into, I'll break it apart now using this formula. So it's going to be tan of 135 plus tan of 60 over 1 minus tan 135 times tan of 60. So now I'm going to go to the unit circle and find tan of 135. And I can see that that is just a negative 1. And tan 60 is rad 3 over 2 over 1/2. And so if I multiply by the reciprocal there, it's just going to give me rad 3. So tan 60 equals rad 3. So this will be negative 1 plus rad 3 over 1 minus negative 1 times rad 3. Now, I have to multiply these together first on bottom. And so this is going to become 1 plus rad 3 on bottom. All right, and so now I want to rationalize the denominator, so I'm going to multiply by the conjugate of the denominator, which is 1 minus rad 3. Now when we do these, we know the bottom we can do a little shortcut and just do fl, whereas the numerator will require a full FOIL. So the denominator is just going to be 1 minus 3, and the numerator will be negative 1, plus rad 3, and plus rad 3 will be plus 2 rad 3, and then minus 3. So as we simplify that, which I will do over here, we're going to get negative 4 plus 2 rad 3 over negative 2. And then if we reduce all three of those together, it comes out to 2 minus radical 3. So that's what I would put. All right, next up here, it's in this case that we see an expanded version of one of our formulas here. I actually think that it is this one up here. So you can see it's sine of something, cosine of something else, plus cosine of the first thing, sine of the second thing. So we're going to move it back into this form. So this is going to become cosine of 19 plus 26. And so I'm going to simplify that and say cosine of 45 degrees. I think it is important that you put that degree symbol there. And so now I have to find its exact value. So I'm going to go do cosine of 45 degrees, which is rad 2 over 2. All right, 23 is very similar to the previous problem. You're going to kind of put it back together using the angle addition formula for tan and then evaluate it according to the unit circle. I'm going to move on to our graph here. And so the period for tan and cotan is always pi over k. So in this case, k equals 1. And so I'm going to say the period is just pi here. And next up, we are going to find the correct graph. Now I know that cotan is always decreasing, so I'm going to cross off both of these that are increasing. And then it looks like the difference here, and I can see that we have a phase shift here of pi over 4. So that means it should be starting at pi over 4. And so the question here is, does cotangent start at an asymptote or a kind of midpoint there? So to do that, I would kind of look at the first spot on the unit circle. Let me draw that. I'm going to draw the circle. The first spot over here we know is 1, 0, which means the cotangent is 1 over 0. And so that would mean that we should be starting at an asymptote. And so I'm going to say the answer is right here because that one starts at the asymptote. Once again, shifted to the right, pi over 4. All right, next up here, determine the period. So this time, again, for tan, we have pi over k. So k is 2, so I'm going to do that as pi over 2. And so let's see, if the period is pi over 2, I can actually already cross off this one because from asymptote to asymptote period is actually a space of 2 pi. Here it's actually 4 pi, so that's even worse. Here it is actually pi, and so that's not it either. But from here, from negative pi over 4 to pi over 4 is a distance of pi over 2, so I already know that's my answer. All right, next up here, we're picking the correct graph for 2 secant of theta. Now, I know that this is going to be related to cosine of x, and so I'm going to always keep that in mind. First of all, I'm going to cross off the tangent ones right there, and this one looks like a cotangent. And so what I'm going to do next is I'm going to think about what should the graph of 2 cosine look like. And so if I kind of visualize that, cosine starts at a high point, and then it should kind of go like that. And so at this y value of 2, I should be able to kind of find a point that meets there. And so this one is already above it, and so that is not looking like it's going to match up here. You can see like it doesn't go high and low enough for that. They should be really matching up at those vertices there, so that's not it. This one's looking really good here. You can see the high point at 2, and then this will drop down to the low point at negative 2 like that. And so that is what we're looking for. The asymptote should match up with kind of the midpoints there, and then the vertices should match together. This one does not work because, as you can see here, yeah, this would be looking like something like that. And so it's not really matching up correctly with the high points to the high points, so it's definitely that one. All right, next up on this one, all right, so we have first of all, we want to find the amplitude. The amplitude here is actually 3. Even though it's a negative 3 there, the amplitude must always be positive, so it's going to be a positive 3. The period for sine and cosine is 2 pi over k, and so in this case, that's going to be 2 pi over 5 pi, and that'll reduce to 2 over 5. So we should not have any pi's in our scale here, so I kind of already know these two are incorrect. And then the other thing I kind of notice here is that if we have a negative cosine, the negative cosine will always start at the low point and go up from there. And so I'm going to say it's got to be that one. All right, here's number 28. I'm actually going to do the next one. All right, next up here, what do we got? Okay, so we got one completed graph of the sine curve. So the first thing I'm seeing is we have a phase shift to the left pi over 4. And so, because sine kind of, this is the shape of sine if it starts right here at that midpoint. And so I'm going to say our horizontal shift is negative 1/2, not pi over 4. I don't know why I said that. Negative 1/2, okay. Next up, amplitude. It looks like the amplitude is 4. And then the period here is going from negative 1/2 to positive 1. And so that's 3 over 2 or 1.5. Now, all right, so that is the period right there. Now, remember for that, as we go over here, I already know that this is going to be 4 sine of, and I need to figure out what k is, but I know this is going to be x plus 1/2 in there. Because k is equal to, no it's not, the period is equal to 2 pi over k. So we know that the period here is 3 over 2, so that's going to be equal to 2 pi over k. And I'm going to go ahead and cross multiply here to figure this out. So 4 pi equals 3k. K equals 4 pi over 3. So that is going to be, oh, that's not my answer, but that's going to go right here, 4 pi over 3.